today we are going to derive the Schrodinger time independent equation. Before we derive the Schrodinger time independent equation, we should know what is the time dependent equation, because the correct way to derive the Schrodinger time dependent equation is from the Schrodinger time dependent equation. So first we are going to derive the Schrodinger time dependent equation, which I have done in the last class. You can check the lectures for that. And from here we are going to find out the Schrodinger time independent equation. So let's start with the derivation. Before we start, certain concepts are important. For example, separation of variables. That means that if you are having a function like this, which is actually a first order differential equation, you can take all the y terms on one side and all the x terms on one side, and you can see that we have separated out the variables. Now you can integrate and find out the equation for this. In a similar way, as we said during the Schrödinger's time dependent equation, this term psi is actually a function of x and t, that means position and time. So we are separating it out into two functions. One is a function of only position and the second one is a function of only time. Also, we have seen in the last class that the value of the wave function, we can usually write it down as psi is equal to psi naught e to the power I divided by h cross into ex, or we can write it down as px minus et. We have derived this relation in the last lecture, and you can check it here. Okay, usually we start with the basic expression for psi e to the power kx minus omega t, and after doing all the changes we can write it down as I by h cross px minus et. Now you can see for this we have got the term del psi del t. So what we'll do now is we are going to differentiate this term and find out what is the value of del psi del t. So let's try finding out del psi and del t. So this can be written as, psi naught is a constant, so you can take it out and I can write it down as del t of e to the power I by h cross into px minus et. So now if we differentiate it, we can have it as psi naught into e to the power I by h cross, because ddx of e to the power x is e to the power x. So we can write down this term px minus et, and then we are going to differentiate with respect to t the term I by h cross into px minus et. Now let's just simplify this. This entire term is actually nothing but psi, so we can just write it down as psi, and then what you can do is you can differentiate this. So here I can write it down as e divided by h cross. We're talking only about differentiation with respect to t, so we can ignore this term, and then we can just write it down as minus of e. Now if we do certain adjustments on this side, what we can do is you can see there is an I, so what you can do is multiply the numerator and the denominator with I, and finally we can have it as I into I square is minus 1, minus minus will become plus, so I can simply write it down as E into psi divided by I h cross. Let's cross multiply this with this term, so therefore we can say I h cross into del psi del t can be written as E psi. Please note, psi we are talking here is a function of both position and time. So let's mark this expression as expression 2, and we have this expression, and let's mark this as expression 1. Now what we can do is we can replace 2 in 1. So let's just do it. Replacing 2 in 1. We can take this entire term and this can be written as E psi. So we have it here. So I will simply write it down as E psi is equal to minus h cross square by 2m into del square psi del x square plus v psi. Now we are going to use the concept of separation of variables. So as I said that I can have the function of psi as x and t, and I can separate them out into two different functions of psi x and phi t. So let's do it. And here what I can do is maybe I can write it down as psi into phi. We know that psi is a function of x and phi is a function of t. So let's just do these replacements here. So what you can do is you can simply write it down as psi into phi, and on this side we can write it down as minus h cut square by 2m del square del x square. Now we are differentiating it with respect to x, so that means psi is the variable and phi is only a function of time, so we can take it out of the differentiation sign. We're going to do it v, and again psi will be this and phi will be this. Now please remember, if you stop here with the derivation, it's partial and you cannot derive only up to this point, because until this point we are saying psi is a function of x and t, and here we are differentiating a function of x and t with respect to x, right? But we're talking about the Schrodinger's time independent equation here, so we have to get rid of that time. Now what we're going to do is we're going to divide both sides by psi, or we are going to divide both sides by phi. Okay, we can divide both sides by phi. Here I can just simplify it a bit further. I can write it down as minus h cut square divided by 2m, and this phi is a function of time, it's not a function of x, so I can take it out, and then I can write it down as del square del x square psi plus v into psi into phi, right? So what you can do now is we can divide both sides by phi. So let's just do it. So dividing both sides by phi, the time dependent term. Here on this side, if we do it, we are going to get the term as e psi is equal to minus h cross square divided by 2m, and this would be del square del x square into psi, because we've divided it by phi, so this phi, we're getting rid of this phi here, dividing this by phi, right, dividing this by phi, and on this side if we divide we again get rid of the phi, so plus v times of psi. Now what we are going to do is we're going to do certain adjustments, and then we are done with the expression. So we can take this term on the left hand side, and there is a minus sign, so it will be plus, so I can write it down as h cut square by 2m del square del x square into psi. Then I can write it down plus e psi, which was already on this side, plus e psi, and v psi can be taken on the other side. I can write it down as v psi is equal to 0. Almost done. One final step. H cross square divided by 2m into del square del x square into psi, plus we can take e minus v common, and we will have psi outside is equal to 0. Now if you look into different books, they will show that this psi is probably written, I've written it here like this, it may be have been written like this. But the main point is this is a function of only position. So the psi that they are being mentioning, it's only a function of position, because we are deriving the Schrodinger's time independent equation. So if you're deriving it, you have to derive it up to this particular point. So if you are being asked a question on Schrodinger's time dependent equation, you are going to derive what we did in the last class. If it's for the time independent equation, you are supposed to derive this, but then always start from the Schrodinger's time dependent equation. Take this Remember this result of psi naught, psi, and then differentiate with respect to time, replace it here with e psi, and then do the separation of variables and divide throughout by the function of t. That's it. So after